How's it going? Excellent. I know we are between you and the lunch hour, and you're probably very hungry. And I'm sure you're having a very big data overdose, right, so far since morning? So I want to start off with a joke. I know nobody has said a joke so far, so I said, let's just do it. Either you're going to laugh at me or laugh with me, right? So here's a small shop owner, working very hard, and suddenly he says that on his left, a new store opens up. And the guy has the biggest, baddest sign that says, best deals. So the shop owner is really dismayed. The next day, he gets up again next morning, he goes in, and then he sees a store on the right, another new store. And the guy puts on the biggest, baddest sign that says, lowest prices. So now the shop owner is in a panic mode. He's like, what to do, what to do? So he goes on for a walk, thinks for a while, then settles down, comes back. He has an idea. The next morning, he puts up a bigger sign than all the stores out there that says main entrance. That's what TiEcon is. We are the main entrance to all the entrepreneurs here. Thank you all for coming. So with that, I'll be done with my jokes now. With that, I'm going to keep going. No. I want to introduce an amazing panel that we have today. These guys are working really hard, so I really thank them for coming here. On my left is Mike Abbott. Mike is an investment partner at KPCB, which is Kleiner Perkins. Always forget the last two words. Okay, and buyers. Thank you. We have Sam Shah, who is a principal engineer at LinkedIn. How are you doing, Sam? And we have Tim Campos. Tim is the CIO at Facebook. How are you, Tim?
All right, how you doing?
Since all of you know what they do, you have the bios in front of them. So what I'm going to do is actually put them on a spot here and tell us one thing that we don't know about them, starting with Mike.
One thing that you don't know about me?
Yeah.
I'll give you two.
That's even better.
I'll even surprise you there. Despite being a general partner at Kleiner Perkins, I still write software.
Oh, wow.
Recently wrote software using computer vision technology on the iPhone to estimate when my daughter would actually fall asleep.
Amazing.
And then other fun fact is I ran the Inca Trail in Peru to Machu Picchu from Cusco.
Oh, that's amazing. See, that was on your bio. Thank you, Mike.
Yeah.
How about you, Sam? Tell us something we don't know.
Sure. I decided to go into computer science because of a flip of a coin.
A flip of a coin?
Yes.
You're serious?
I'm serious.
And the coin said heads or tails?
I don't remember exactly what it was, but it was between computer science and math.
But it said computer science?
Yeah, it said computer science.
All right. That's amazing. How about you, Tim?
I'm gonna pick up on yours. And the reason I got into computer science was because of my wife. And this year we're celebrating 23 years together. She's my high school sweetheart. So.
Wow, that's amazing.
That's
How
awesome.
about that?
That's great.
Don't ask me how many years. You're going to put me on a spot here. So we have an amazing panel on big data. I know a lot of us heard about big data since morning today. I mean, it's really an explosion. And if you think about it, according to an IBM study, every day 2.5 quintillion. Anybody knows quintillion? That's 10 to the power 18 of bytes of data is created every day around the world. So this high volume, high velocity, and high variety of data is mind-boggling. But that's just all over. Let's think about social networks here for a change. We have someone who worked at Twitter. We have LinkedIn and Facebook. So I'm going to ask this gentleman a question here. How much big data is being created on your networks every day, and what are you doing with it? So let's start with you, Mike, with your Twitter experience. Yeah.
So I'll first actually expand on your comment on the numbers.
Yeah.
There was another report that came out that 2.8 zettabytes of data are going to be created this year alone. But what's interesting is that despite that amount of information, which is huge, only 1% of that, or actually less than 1%, is actually being analyzed.
Amazing.
And that actually influences a little bit of how we look at investment, but I'll get into that later. Twitter, it has a large infrastructure. I'm not speaking on Twitter's behalf. I ran engineering there, built most of the teams there. But today, the company generates about 100 terabytes of data a day.
100 terabytes, wow.
Is that right? Yes. That was recently released in March of 2013. And it also has tens of thousands of Hadoop nodes actually running. So it's a lot of infrastructure. But I think like with any of these large companies that are collecting a lot of this data, user data and system data, it comes down to like how are you actually using it in meaningful ways.
True. Sam?
Yeah, so we store a lot of data, petabytes from, member profiles to what people share on the network to SlideShare presentations. I think the really interesting part of it is like the value add of the data that we can provide to it. So we released a feature recently, maybe 6 months ago or so, about endorsements where you can provide a lightweight kind of feedback around skills of people's profiles. And we have this, large mass of skill reputation data. I think we have 1 billion data points. And the nice thing about that is you can say like, oh, if you know what people's skills are, you can say, oh, for a military officer, a radio operator, what would be his career path getting out of the military? You can look at previous people and what their skills have changed. You can look at how do we fix Detroit, right? Can we look at skills of similar cities and how they've migrated and what's the skill set around that? And so we're taking things which are, used to be done with small sample sizes of, 20, 50, 100, and now we can kind of scale those across like 200+ million people, across professionals all over the world. And that's generating a ton of data.
Excellent. Okay.
So at Facebook is really just an extension of the same story. And so, there's how much data we're capturing on a daily basis depends on which data you want to talk about. If you want to talk about photos, you want to talk videos, you want to talk about the analytic systems. The data that I care about is the data that's in the analytic systems, because that's what we can use to create value, not just for our users, but also for our advertisers, and to also help us just run the business. And so we are a giant Hadoop ecosystem. We're generating hundreds on the order of petabytes a day. Net, we are going to be saving roughly half 300 terabytes a day worth of analytical data in the Hadoop ecosystem. Really, one of the big challenges for us is as this scales, I mean, this is data that you don't really want to throw away because you want to be able to build long-term trends. And so, one of the challenges that I think all of us face is, as time goes on, where is this stuff going to go? Yeah. And I look forward to talking about that in a few minutes.
That's great. You mentioned a couple of things there. I mean, I think the key is what are the drivers? What is causing this big data? I mean, is it availability? Is it mobility? I mean, what is the key driver, and what is the trend?
Well, I can speak to the trend. So we talked about the 2.8 zettabytes. Yeah. That same study projected that we'll be at 40 zettabytes in 2020. Right. But what's interesting is that what's driving most of that growth is actually machine-generated data on you, and that could be in the offline world or the online world. Okay. And so that, again, for us looking on the investment side, we're saying, okay, we've got companies that are collecting data. We're not sure. We're using it for applications and services. We're not sure in the future what data we want to actually use. Right. And I think we have to all be really careful around ending up in this like data obesity problem where we're storing everything because we're not sure what we're going to actually go use. Sure. But how do you actually extract value from it, I think remains an opportunity, at least in our view, to still invest in companies. And we do have invested in companies around targeting those types of problems.
Absolutely.
I think the core driver here on growth is it's really the outcome of Moore's law. Right? Okay. So as the cost of compute goes through the floor, then the ability to track and manage all this information is inversely proportional to that. And so the other factor, I think, is also the interconnectedness of things, that the ubiquitous network connectivity that you have, not just on the internet, but with mobile networks, it creates the possibility to track and manage everything. And so it's not just social networks that are doing this. Everybody is tracking and managing everything. And there's huge opportunities in this. So that's the reason not to throw the information away, that even a telco company can build lots of predictive analytics off of the call flows, which will help them manage their business, figure out where to grow their networks. And so this is the opportunity that we face today in technology, is that it's become so cheap to manage this stuff and to compute it and to analyze it, that that's what's ultimately driving, I think, the tracking of all this information.
That's great. Sam,
yeah, I mean, I agree with the panelists. I mean, basically, the infrastructure has allowed us to keep this data, and so we have the ability, and now I think we have to basically figure out what's the value add from the ability to keep all this information.
So here's an offbeat question. I mean, when I search for something on the social networks, which many of us do, like today's event, TiEcon is going on, and a lot of us are hashtagging on Twitter and other networks, with the hashtag TiEcon. What comes up first and why? I mean, how is this analysis happening behind the scenes? If you can give us a little color of that.
Well, I mean, certainly in the case of Twitter, I mean, real-time search is different than just a traditional IR problem.
Okay.
Right? Because the service is focusing on how can we deliver information to you that was just tweeted at this event. Someone tweets, how can you actually see that tweet?
Right.
So you have kind of an interesting read and a write challenge from a technical perspective, which is unique.
Okay.
Yeah, I mean, I can even start with before search on LinkedIn, right? When you go to the homepage, the portal, you see a news feed which is built by algorithms.
Okay.
You see a bunch of articles that are either on-site or off-site, again, targeted to you. You see on the right-hand rail, you see a bunch of recommendations for you, people that you want to maybe connect with, jobs that you might be interested in. You see analytics on people who viewed your profiles as a virtual kind of handshake. So like the main portal of LinkedIn is just basically built on this large-scale machine learning. We even show an ads, to make some money. And so, you can see that just like the homepage has that kind of deep machine learning, and that permeates through the rest of the site as well.
That's very true.
Yeah, so I mean, without the capability to analyze and process, billions of elements of data in seconds, Facebook wouldn't work. This is one of the things that enables the site. So when you log into Facebook and you go through your news feed,
right.
There's a bunch of calculations that are going on based on data that we have. So who am I connected with? Therefore, what's the population of stories that I should see? Who am I most connected with? Who do I engage with? Who do I send more Facebook messages to? So that we can then prioritize that list of stories by the stuff that you're more likely to be interested in. There's a little bit of art in here as well. Like, how do we want to weigh different things? People you haven't spoken to for a while. The advertisements that are going to show up in the feed. What are the things that are more likely to drive engagement for you as opposed to cause negative sentiment for you. And all this is happening based on information that we've captured that then feeds statistical algorithms that have pretty high degree of accuracy in terms of being able to predict what's going to be interesting to you. And it's processing this stuff in microseconds. And that's how the feed works. So yeah, and it's just an incredible world that we live in today that we can do all this stuff in such a ridiculously short period of time.
Well, that's interesting what you just said there, Tim. I mean, I log into Facebook, I'm always curious, like why this thing appears here and why it's not there. And so you're saying there's definitely a lot of analytics behind the scenes that's doing it. Well, what about my preference? What if I don't want to see your update on Facebook? I'm just kidding, but what if that's the case? How do you put that in the mix?
Yeah,
How do you put a user preference about what he or she wants to see?
And we do this both in active and passive ways.
Okay.
So the active ways are simple things, features on the site where you can say, I hide this post from my newsfeed, I'm not interested in it, or block it, I don't want to see this user anymore, or report this as spam. So those are all active things that that the user can provide. But the passive things that we look at are what's engagement like? Do you stop halfway through scrolling on your news feed because you're disinterested in the content?
Right.
And how is that trending over time? And we use that to then fine-tune the algorithms in the product to make sure that we're optimizing for engagement. If we start sending too many advertisements down the pipe, that's a problem. If we start sending too many things from people that that's a problem. If we start sending too many things from people you don't know, that's a problem. So all this has to be balanced, and it is there's a lot of machine learning in here. The systems are figuring it out in part on their own, but we're also helping to educate them with just looking at studies and how the data is trending over time.
True, and I think LinkedIn has changed quite a bit. I mean, Jeff talked about earlier today about the LinkedIn influencers, where you get the news stories from the likes of Richard Branson of the world, and people that we all like to hear what they're doing and what they're sharing. How is that going on? I mean, how do you know that I would like to see Richard Branson's story and not Tim Campos' story? I mean, what are you guys doing there?
So maybe it'd be good to give me a quick 30-second history of what happened. So maybe 2006, 2007, we had this product called People You May Know, which was a link prediction, trying to find other professionals on the network and that was doing very, very successfully, but we couldn't scale it.
Right.
It was continually having problems, and if people say that pornography changed a lot of the internet. Well, people you may know was the pornography for LinkedIn. It changed a bunch of the systems that we built. We built a lot of new machine learning data infrastructure systems to do that. And then we've basically, in the last couple of years, we've leveraged this across many different kind of platforms. So influencers, job recommendations, et cetera. And you can look at a lot of signals. For example, if we show you a type of article, but you don't interact with it, if we show you that to you enough, we kind of get an information about your preferences.
Okay.
We have information in your profile, right? What information do you put in there? We can extract text and skills and your history, your seniority out of your profile. We can look at your connections and see who are you connected to and understand what their preferences are and kind of impute those to you. So there's a lot of different diverse signals that you can put in to decide that someone is interested in a particular piece of content or not.
Excellent, excellent. So a lot goes behind the scenes, and actually that's kind of what my next question was. I mean, it's incredible the amount of data that's being created. Can you share with the audience in not probably as much technical speak, if you may, how do you manage all this? I mean, what is it? You put on a bunch of servers? I mean, just give us some color on that.
Well, I think the most common setup is that they set up a Hadoop cluster or one of the other distributions to basically be able to store that data and then run MapReduce jobs on that. And I think a really common architecture is to use some type of log collection infrastructure, Scribe or whatnot, take the logs, dump it into Hadoop, run MapReduce jobs where you take the output of those jobs and you may put that into a secondary system for analytics. So that might go into Hive, it might go into Vertica, and then enable business users to go query that. There's dozens of teams at Twitter that run pig jobs on Hadoop kind of directly. I think the answer has to be self-service for any company. How do you actually enable everyone to ask questions of your data? And I think that's one of the key things here is it's really efficient to store, but I think part of how you extract the value is enable everyone in the company to be able to ask as many questions as you can and get those results. And that's what you really want. You want everyone kind of empowered to be able to go do that. And I wouldn't say we're 100% there. Any company is. I mean, Google's actually probably arguably the furthest along in this. But I think that's the goal probably of all of our companies.
Yeah, to add to that, I think, be able to ask questions. I think the other thing that's really important is being able to get the data in and be able to get the data out, right? If you need to go and get some piece of information to answer the question, you shouldn't have to go and talk to like 10 different people and figure out where is it like hidden somewhere and what does it mean and stuff. The data needs to be cataloged and easily available for people to kind of go and query and answer those questions. And once you have that, the answer to that question, you want to basically be able to publish it in some way, either back to the end user, on the site, or as a reporter. And those are like two areas that are still kind of open problems in this space. That there isn't easy mechanisms to get the data in as well as to get the data out.
Tim?
So I think for us, just to add to this, one of the key things is it really starts with automating everything. You cannot manage large-scale environments without deep levels of automation at all levels of the stack. A second core thing is that we have systems architectures which basically completely accept they are designed for failure. You do not expect that every single bit of equipment in the chain is going to be fully available. Therefore, you have to have the right level of data redundancy, the right level of replication. We have, to keep the cost manageable, we've focused a lot on the system designs, both the way the data center is designed, how the hardware is designed. We've open sourced the hardware designs themselves so that we can invite others to contribute to that design, which helps to spread out the R&D costs, but it also, the more people that are investing in open compute, the more that drops the manufacturing cost for that type of equipment. And then the automation continues when you start thinking that more at the logical layer. How do you get the data off of the site and into the analytics systems? How you build the pipelines that then start producing some of the aggregated analytics. We also layer up the system that it's not everything goes all the way down to Hadoop. Hadoop is a tank. It can deal with massive amounts of information. It's also pig slow. And so, in-memory systems, traditional data warehouses, other things, get layered on top of the ecosystem so that we can have, scaled interactive analytics on the environment. So there's a lot. I mean, this is a really rich topic. I could probably talk all day long on how do you manage an environment like this, but I'd say the core principles are automate everything, design for failure, and then find ways to drive as much cost out as possible.
That's great. So we are in the midst of many entrepreneurs here, who are here, to learn more about big data and all that. A question for you, I mean, what opportunities you can create for this next generation of entrepreneurs here? I mean, how can they tie into, if you may, your big data initiatives at your companies, as partners, maybe as collaborators, maybe as potential, companies that you probably want to acquire later on down the road, if you can share some color on that.
Well, I think I can comment to that more appropriately as a VC from Kleiner Perkins of what opportunities, because we're spending a lot of time on this space. And actually, what Tim mentioned is one which is around just real-time analytics. I mean, there's a number of startups that are looking at how can you use a streaming data management system to actually be able to run operators just faster or run them all in memory. And there's different kind of approaches to go solve that. But Hadoop's slow. It's slow to do MapReduce jobs. People want to run more queries. Like, how do you address that? I think another area that I'm particularly interested in is if you look at the intersection of these, there's all these sensors. I mean, your phone has numerous sensors on it. There's a bunch of data generated off those sensors, and you apply machine learning to that, and what kind of interesting new application services are going to be built around that. And that could be an enterprise or the consumer space. And so, as an example, is if you believe that we'll have driverless cars in 7 or 10 years, what are all the pieces that we're going to have in place to go do that? And I think in particular, some of the advancements that have been made in deep learning is in a particular area that I'm spending time on.
Excellent. Sam?
Yeah, I mean, to add to what Mike said, I think that the machine learning algorithms have changed quite a bit. So we've been really getting a lot better in image processing, natural language processing, think like Siri, as well as in the mobile device space, the compute power has increased quite a bit, as well as the high availability, high bandwidth, low latency kind of mobile connections. And then you can marry those things together and you can create a lot of new class of applications. Kind of the ubiquitous computing revolution is going to happen. And if you think of something like the Boston Marathon, a lot of those things were caught. We had a lot of information based on people's phones. Think in 5 years what's going to happen, right? When everyone has a sensor on all their phones and we have a multitude of sensors, what can we really do with that information? As well as what can we do with collaborating with other sensors that exist in the same environment.
That's fantastic. Tim?
One of the things that I'm most excited about in today's world, I've been in IT for a while, for about 10 years now, and much of the last 10 years has been focused on really boring IT problems. Just how do you drive cost out, how do you outsource, how do you, even cloud computing and BYOD and all those kinds of things, I don't find, those aren't the types of things that are strategic and innovative for companies. But when you get to data, data is where IT can really shine, because there's only one function in companies that consistently has the information assets of businesses. And as those assets scale, as we have more and more data, it's really the head of IT's job to go figure out what they've got and use that to build up something that can create business value. And there's so many examples of this. LinkedIn's People You May Know is a great example where they use past data to then make the site more engaging and enriching, and it paid off in a huge way. Amazon has Products You May Like, same type of idea. Like, let's look at other people who demographically look at like me, what they've purchased, and then come up with some predictive algorithms on things that I would be interested in. Every company has the opportunity to use the data that they have to create information assets. In some cases, information assets that they can sell, that become something that is a business in itself. Look at ADP, for example, with payroll data, and they provide economic trending analyses because they know how much people are getting paid and how that's trending over time. So this is the opportunity that companies have, and where it gets really exciting, going back to your question about how can companies leverage Facebook. or Twitter or LinkedIn. It's when you can start enriching that data with other data sources. So you may have a bunch of hotel transaction information, to the degree that you can join in with Facebook and FB enable your your loyalty program or whatever, then you can get a lot more rich information about who your consumers are, who your customers are, and that's where I think the next 5-10 years are going to be for technology organizations, is finding these opportunities to both mine and enrich your own data, and then combine it with other people's data sources to create something that's of real business value.
That's great. So we are a little bit over time, so what I'll give you is all 30 seconds, your parting shots, please, on big data. So let's go with Sam first.
Oh, wow.
30 seconds.
Okay. So I think that there's a lot of opportunity for big data, especially in other kind of computing platforms outside of social mobile. I think that space has been used a lot, but you can look at healthcare, and there's going to be a lot more kind of personalized healthcare around these things. You can see something like Angelina Jolie's op-ed in the New York Times a couple of days ago, where she talked about DNA sequencing. The test was $3,000. Just the cost of the test, but in a few years it'll go down to $30. And what's the big data implications of using that, providing personalized healthcare? I think will be really great for not only business opportunities but for humankind as well.
Tim, 30 seconds.
So I think big data is not a buzzword,
It's not a buzzword.
and I almost wish we didn't have a buzzword for it. It's a strategy, and it's a strategy which I think every company that embraces and focuses on it is going to be rewarded economically in spades. This is where IT organizations need to be spending their time moving forward, is on analytics and building out information assets.
All right, with that said, thank you all for the panel, and I'm going to have Mike go with 10 seconds. Okay.
I think it's less around big data versus important data.
Yeah.
Okay.
And I think it doesn't necessarily mean volume. And I think there's a lot of important things that can be kind of pulled out of that. And I'm really excited to see, what new applications are built around this. I mean, when Siebel and other applications were built 15, 20 years ago, they didn't think about big data in mind. And I think we're going to see a whole class of applications that are actually emerged just from this infrastructure being built.
Excellent. Thank you all, panelists.
Thank you.
Thank you.
Thanks, guys. Sorry to break the party.